You can say, well, we can do something called helioseismology, which is really like looking at solar earthquakes, if you like, solar quakes, and looking at the way the sun oscillates and rings. And you can use that to measure the amount of helium as a cross section through the sun. So we know that the sun shines by making hydrogen into helium in its core, which would suggest that there should be more helium in its core. And we know how bright the sun is, we know how much energy comes out, so we know the rate of nuclear reactions that we need to produce that amount of energy. So we can look and see how much helium's there, and that tells us how old the sun is. And you get the answer, which is about 4.7 billion years or so. So from a completely different measurement, you get a measurement that's consistent with the age of the Earth. So you build up this picture, in this sense, cosmology, from many different measurements, and they all appear consistent. So then you judge, if you make a measurement that jars with that whole lot, then it gives you a sense of that makes you perhaps suspicious. If it contradicts the whole swathe of other experiments,